Welcome to Ask and Learn.
So they want us to find the least number of comparisons to sort four items. And then they want us to come up with an algorithm to do this. All right. So what they mean by least is if you do this many calculations, you could always ensure that you get it no matter what. So there is possibly that you get lucky and you could do it in less than this, but at least for our purposes, it will be at least this many for our algorithm. All right, so let's see. So we can do log base. So they tell us in the chapter that if we do log base 2 of the factorial of how many items we have, then this will give us an idea. So this is going to be log base 2 of 16, and then 16 is equal to 5. So we should be able to do this in 5 steps. And no matter what, we'll be able to sort these completely. All right, so anytime if you're unsure of maybe how to start, just start with a simple example and see what you could do from there. So let's start with 4 elements. So just 2, 5, 10, and 7. All right, so why don't we compare these first two here like this? So that's going to be 2 comparisons. Well, in this case, we know that 2 is going to be less than 5 and 10 is going to be greater than 7. Okay. Well, then for our third comparison, why don't we figure out what our um, largest element is going to be? So we could compare the two largest here. So we could do 5 versus 10. So then that's going to be where 10 is larger. And now what this implies is 10 is our largest element. All right, now for our fourth one, let's figure out what our smallest element is. So we can do 2 verse 7, which then implies that 2 is our smallest element. Okay, so let's go ahead and write up here in the corner what we have so far. So we know that 2 is our smallest, we know 10 is our largest. So what we need to figure out is where does 5 and 7 go in this? So the last thing we're going to do is compare 5 and 7. So then 5 is larger or less than 7. So then that means it would be 5, 7, like this. And notice that here we get it in this many steps. So why don't we go ahead and redefine these? So instead, I'm going to call 2a 5b, 10c, and 7d. Or actually, better yet, what I'll do is let me switch these positions here. So I'm going to switch the 5 and the 2. And you'll see why I want to do this in a second. If it'll let me move the 2. All right. All right, so we're just going to say we have A, B, C, D. So now let's just go ahead and plop these letters down everywhere we had those. So 5 is A, C is 10, 2 is B, 7 is D, and then 5 is A, and then 7 is D. All right, so now there shouldn't be an issue with, oh, I need to move this symbol around now though. So it's going to be like that. All right, so there's not an issue with us moving these around though, because you could just always say, okay, well, we compare 5 and 2, now let the largest one just be A. So that won't be an issue. And we'll also say that in there. But now we have a nice outline of how to do this. So we just group them together, compare, then we take the two largest elements, compare those, take the two smallest elements, compare those, and then we take the non-largest element and then compare it with the non-smallest element. So maybe I should write that off on the side here. So This is compare largest, compare smallest, and then compare the other two. All right, so that's the process we're going to follow through. So let's go ahead and start with the algorithm. So first thing we're going to do is compare A versus B and C versus D. And now what we're going to do is allow for A to be larger than B and C to be larger than D. If not, just redefine the letters. Or maybe I should say the elements. Because these may be something else. All right, so we have that. So that was step one. So that's two comparisons. All right, so now for our third one. So now compare A and C. Whichever is larger is our largest element. All right, so we got that first one. So now what we're going to do is now compare B and D. Whichever is smaller is our smallest element. And then lastly, we want to compare the non-largest and non-smallest from the third and fourth comparisons. This will have sorted all of the elements. All right, so that's essentially one algorithm. So you could also come up with a slightly different algorithm that also gets it in 5 sorts. This seems, at least to me, to be the most straightforward, at least for the example that I cooked up. And so again, like I was saying, if you're ever having troubles with coming up with an algorithm or something, just come up with a small example with actual items, numbers, whatever the thing is asking you to create the algorithm for, and then see if you then can go back in and replace all of your objects that you selected with just arbitrary elements, and then see if the algorithm will still result in the same thing. Because this is normally what I would do for it.